Bismillahirrahmanirrahim. Today is our lecture number 23. We have studied lemma 4. So lemma 4 states that the following diagram of R module and their homomorphism. Basically, this is the generalized form of lemma 3. In lemma 3, we have studied only this sequence diagram, like it from A to B and B from B to C. We cannot study this part. But here in lemma 4, we add this part and say that what this diagram is commutative with two rows of exact sequence D. Alpha, gamma are epimorphism and del is monomorphism. Alpha, gamma are epimorphism and del is monomorphism, then so is beta. After this, alpha is epimorphism and beta del are monomorphism. Implies that gamma is R monomorphism. So basically we have proved the two parts in this theorem. I hope this theorem you feel very easy, because yes, in the last class you have already studied lemma 3, so this is basically a generalization of lemma 3. So this is, I think, 90% is similar to lemma 3. So we have started the proof of this theorem. From here, first of all, I told about the composition of function. So beta composition F is equal to F dash composition alpha. After this, gamma composition G is equal to G dash composition beta. After this, del composition H is equal to H dash composition gamma. So you have these things are keep in your mind, because again and again we are see from here I say beta composition F is equal to F dash composition F. It's very difficult for me. So you look here, and we have by taking here from here we have proved that what beta is R epimorphism. Basically we have proved that beta is onto. So by hypothesis, what we are gained, since the diagram is commutative, this is given in hypothesis, and so beta composition F is equal to F dash composition alpha. I also revised before. Gamma composition G is equal to G dash composition beta, and del composition H is equal to H dash composition gamma. From here, gamma composition H dash is equal to H composition gamma. Like from here is equal to here, and this is equal to this. Further, is the row or exact sequence. So image of F is equal to kernel of G, image of G is equal to kernel of H, image of F dash is equal to kernel of G dash, and image of G is equal to kernel of H dash. From here, image of F is equal to kernel of G, image of G is equal to kernel of H. From here, image of F dash is equal to kernel of G dash, image of G dash is equal to kernel of H dash. So this is also given in we are taking from above diagram. So we have proved that beta is onto. So start the first part of this theorem. To prove beta is onto, let B dash belong to B. This is basically similar to yesterday. We have already proved that, but here we have used three conditions. Here in the last theorem we have used two conditions, like beta composition F is equal to F dash composition F, and gamma composition G is equal to G dash composition beta. We are not used this in yesterday theorem, but here this is extra. Also one conditions, and here also is extra. So by using these things we have proved that beta is onto. So B dash belong to B dash, then we have applied G dash from B dash, is this should be belong to C dash. See the functions in the diagram. See the diagram. Beta B dash is basically from B dash. Basically B dash is taken from here and assigned to G dash. The result will belong to C dash. We are taking C dash from C dash. Smart C dash from C dash, it is equal to smart C dash to C dash. So G dash B dash is equal to gamma C. C belong to C, because gamma is onto. After this we are write again both side H dash. So by taking composition in this side and also composition at this side, so this is equal to basically O to D dash, G dash, D dash, and from here H dash to composition gamma. So this is equal to del composition H by hypothesis is equal to C, and we are write H dash composition G dash is equal to O. So from here We are again reopen the composition of function, so del h of c is equal to 0 in d dash. Again we are write this is from d dash, so we are define a function del dash which is from d to d dash. So we are write instead of this like this. So after this we get the result from both sides d dash, so hc is equal to 0 in d. So when we are taking c from c assigned to a function h, the result will be 0. So this element should belong to kernel of h. And kernel of, by hypothesis, kernel of h is equal to image of g. So c should belong to image of g, and image of g contain like g of beta kind of elements. So for some b belong to b and c equal to gamma of c which equal to g. We are taking both sides gamma. So gamma of c here, from here we are again combine composition of function. So composition of function we have write again gamma composition g is equal to gamma g dash composition beta, and from here gamma of c is equal to g dash of beta c. After this we are taking common g dash, and beta dash b dash minus beta of b is equal to 0. That means that this element belong to kernel of g, because this element we are assigned to a function g dash, the result will be identity. So this element should belong to kernel of g dash, and which equal to image of f dash. By hypothesis it is given up there in the beginning of the proof, the start of the proof it is given. So from here image of f is contained like such kind of element, f dash alpha dash, basically a dash. So from here we have write again f dash instead of our place, and alpha a dash is equal to basically alpha of a. Alpha is defined a function from a to a dash. After this we get a result by combining the composition of function. By using composition of function we have write this. After this we have write b dash minus beta of b equal to beta f of a. Basically this function is equal to beta composition of f. So we have write one step is missing from in here. This is equal to beta composition f of a. So we are open the composition of this function, so we get this. After this we have write b dash one side, and we are move there to beta b to another side like beta b plus beta f of a. We are again common beta and write b plus f of a. For every b dash belong to b, there exists b plus f of a belong to b. This element also belong to b, and f of a is also, if it's a function defined from a to b. So the result is those element is also belong to b, such that b dash is equal to this. So beta is onto. So we prove that beta is onto. After this, what we have proved, basically gamma is 1 1. So for 1 1 we have similarly in last theorem we have proved that beta is 1 1. So there we have used a well-known result. This if beta is 1 1, if only kernel of beta is equal to 0. But here we have proved that gamma is 1 1. So we have used very well-known result. If gamma is 1 1, then if and only if kernel of gamma is equal to 0. This is the identity. So by considering, we prove that kernel of gamma is equal to 0. So this is very similar proof. We are similarly taking element from kernel. The result is when we are assigned to a function gamma this element, the result will be 0. After this we are taking both side h dash. So we are taking composition of function. Here is also this is equal to o n d dash. Here is also we are write again, and this is equal to del of o d dash. After this h dash composition gamma is equal to del composition h c and del o d. After this we are open the composition of function, so del into h of c, and h of c is equal to c, and the result will be del is 1 1, so it will give 0 of d. So we are taking c, a element from a c assigned to a function h, the result will be 0. That means that c belong to kernel of h, and kernel of h equal to image of g, and image of g contain like g of b kind of element. So c should be equal to g of b. After this we are write gamma of c and g of b. We are taking both side gamma, so gamma of c, and we are in this side we are combine the position of function. So gamma composition G is equal to B. After this we get G dash composition beta, because by hypothesis gamma composition G is equal to G dash composition beta, and this we get identity because C belong to kernel of gamma. So here we have get like G dash composition beta of P is equal to 0 identity. That's mean that G dash we are assigned beta B assigned to function G dash, the result will be 0 in C dash. That's mean that this element belong to kernel of G dash, which equal to image of F dash, and image of F dash contain such kind of element like B F dash A dash. After this we are write instead of A dash is equal to alpha k, because alpha is on. We again combine composition of functions. So by composition of function F dash composition alpha is equal to beta composition F. We are again open the composition of functions. So beta into F of A. After this we get the result, because beta is 1 1, so B is equal to F of A. After this we again apply G, so G of B is equal to G of F of A, and G composition we are combined by using composition of functions. So after this we get G of B is equal to 0, because G composition F is equal to 0 and C is equal to G of B. So that's mean that C is equal to 0. We are taking arbitrary elements C belong to gamma. So basically C belong to kernel of gamma, and we prove that C is equal to 0. So we conclude that from here kernel of gamma is equal to 0. So gamma is 1 1 and gamma is R monomorphism. So this is very well known result. Basically in this theorem we have used this is known around this diagrams. If you have understand this, so proof is not difficult. Basically we have proved that beta is 1. So by using alpha, gamma and del, and also by using composition of these, we have proved that the beta is 1 1, and similarly by using alpha, beta and del, we have proved that gamma is onto. So by using these all given conditions, we have proved that beta is 1 1. So for 1 1 we are proved that kernel of gamma is equal to identity. So see that I see from here again beta composition H equal to F dash composition alpha gamma composition G is equal to G dash composition beta, and del composition H is equal to H dash composition gamma. We are get these things from above diagram from here, like beta composition F is equal to F dash composition, this similarly like from here and also from here. We get one thing from here, and the another thing is from here image of F is equal to kernel of G and image of G is equal to kernel of H, and also here taking help from here. So basically these things we are taking from here and prove that by using these other conditions beta is onto and gamma is 1 1. So this is the proof of this theorem. If you have feel any complication, any difficulty in the stage of any stage of this theorem, so you should contact with me. I will help you inshallah. Inshallah we will meet in a next lecture. Allah Hafiz.